What excites me about science is the never-ending possibilities of discovering and making a legacy for yourself. On a trip in high school, I went to Southern Research and I spoke with the scientist and I told her about my ambition of building my own submarine, exploring the depths of the ocean that have not been explored yet. And to my surprise, I was hired as a volunteer in the aquarium department, doing lab tests and maintaining the fish. Academic planning for college was difficult at first, but I came in with an open mind and exploring different fields.
Today, we are going to be discussing the conversion between moles and ground. When I say the word mole, you're probably thinking the animal mole or the birthmark mole. But today, actually, we're covering the unit mole, 0 times 10 to the 23rd power. Okay. This is Avogadro's number, and this number is very important in converting between moles and grams. You probably know that a dozen is 12 things, so a mole is 6.022 times 10 to the 23rd power things, which is a huge number, 6 billion trillion things. This number is so large because it is used to count teeny tiny atoms using their weight. Why is 1 mole 6.022 times 10 to the 23rd power units? Well, because 1 gram is equal to 6.022 times 10 to the 23rd power atomic mass units, or AMUs. Where have we seen something measured using atomic mass units? Well, the periodic table. When you look at any element at the periodic table, this is what you'll see. For example, let's look at the element oxygen. It's number 8 on the periodic table. Its atomic mass is 16. This is the weight of the atom oxygen. So now let's look at another example. Let's look at sodium. Alright, it's number 11 on the periodic table, and its atomic mass is 22.99. Let's look at another example. Sodium, number 11 on the periodic table. So 1 sodium atom weighs 22.99 AMUs, or atomic weight, or atomic mass, and molar mass. These terms are interchangeable. Atomic weight, atomic mass, and molar mass. 1 atom of sodium equals 22.99 AMUs. 6.022 times 10 to the 23rd power atoms of sodium equals to 22.99 grams. 1 mole of sodium equals 22.99 grams. Looking at the periodic table, we see that sodium has the atomic mass of 22.99, or AMUs. When converting, it is equivalent to 22.99 grams per mole, 1 mole. And from there, we do the conversion factor and we cross out grams and grams. And now we're left with moles. Now we're moving on to step 4. Using a calculator, we'll plug in 20 times 1, and we'll get 20. And from there we divide 20 by 22.99. Alright. We'll get 0.86 moles sodium. We are continuing to work with sodium. For this next problem, we are working with sodium chloride. So, the scenario is you're stranded for 3 days on a deserted island.
and you get thirsty, so you drink a liter of seawater. There's approximately 28 grams of sodium chloride in that liter of water. So we are trying to find the amount of sodium molecules in that liter of water. Looking at step 2, we're going to look up the atomic mass. Alright, so sodium is right here, and its atomic mass is 22.99. Alright, and then we have chlorine over here, and its atomic mass is 35.45. Alright, so we have it down here. And then we add them all together, and we get 58.44 grams per mole sodium chloride. Now, let's plug it in. 58.44 grams sodium chloride. Alright, this is equivalent to 1 mole. And now we cancel out. Okay. Next, you'll use your calculator, and you'll get 28 times 1. Then you'll get 28. Divide 28 by 58.44. You'll get 0.47 moles sodium chloride. Now we know that 4.7 moles is sodium chloride, but now we're just trying to find sodiums. So we draw our chart, and we see that the equation is 1-to-1 ratio. So we write 1 mole Na and 1 mole NaCl. So first, you cancel out. Now that you cancel out, you use your calculator. You multiply 0.47 times 1. Once you get that, you divide that by 1. Alright? And you'll get 4.75 moles sodium. So, now that we know the moles of sodium, we are trying to find the number of molecules in sodium. So, if we recall back, we learned about Avogadro's number, 6.022 times 10 to the 23rd power molecules. And this is equivalent to 1 mole in sodium. Alright. Now, we cancel out. Now what we do is multiply. Using our calculator, we will get 0.47 times 6.022 and to 23rd power. Using our calculator, we will get 2.83 times 10 to the 23rd power molecules sodium.